Okay, so multiplying and dividing. We're not going to, it is multiplication and division, but you're not going to actually do a lot of multiplying and dividing. It's more simplifying. It's more simplifying than anything, okay? But just in case, you're going to see a lot of multiplication and division symbols, okay? So rational expressions is a fancy word for fractions, okay? Back in elementary school, junior high, you call them fractions. We call them rational expressions, but they're the same thing, okay? You got a numerator on top and a denominator on bottom. That's what they're called, okay? All right, so before we start, let's have a little bit of a refresher, okay? How do we multiply? What's the rule for multiplying fractions? What's the rule for multiplying fractions? Does anyone remember how to multiply fractions if you have two fractions?
Is it like straight across or like?
Exactly, straight across, yep. You multiply the numerator with the numerator. So 8 times 1 is 8. Denominator with the denominator. 4 times 7 is 28. Then you reduce. The biggest number I think you can divide both of them by, I think, is 4. So if you divide that by 4, you get 2. If you divide 28 by 4, you get 7. So we get 2 sevenths. That's the rule. Yeah, it's multiplying fractions is probably the easiest thing to do because you just go straight across. You don't have to do common denominators. You don't have to do all that stuff. Okay? Okay, so that's the rule for multiplication. What was the rule? Does anyone remember what the rule is for division? It's very similar, but a little different. So close. There's a cross situation there, but it's not cross. So the way we divide, okay, the way we divide is instead of dividing fractions, we're going to multiply by the reciprocal or keep, change, flip, okay? So anytime we have two fractions divided by each other, the first guy is going to stay exactly the same, 4/9. We're going to change division to multiplication. Okay, so division becomes multiplication. We can do that, that's okay, as long as you flip or reciprocal the second guy. So instead of 5/6, we get 6/5. Okay, so I had someone tell me, he's like, how it seems kind of shady. It seems like I just kind of made this up. How does it work? Well, I'm going to show you how it works. It actually is a method. Okay, so there's a division problem up here that is just simple division, right? 12 divided by 2. What is the answer to 12 divided by 2? 6, right? You guys know that. You guys have known that since 3rd, 4th grade. Okay? I'm going to use the same rules I just used on this one to solve this one, and I'll show you it's the same thing. Okay, so first thing is they're not fractions, right? So how do I make numbers fractions? If they're not fractions, how do I make them? What do I need to do? Put a 1 underneath, right? So the rule I just said was keep the first one, change to multiplication, flip the second one. How do we multiply fractions? Straight across. 12 over 2. What is 12 over 2? 6. So that's why it works. So that's why it's actually a true method. You can do that with any division problem. We usually don't because you guys know what 12 divided by 2 is. You guys memorize that. But that works as well. So anytime you're dividing anything, you can always use that method. We only really use it for fractions because it's easier. Okay? But yeah, it works. It does work for any division problem. Okay, so now that we have multiplication, multiply straight across. 24, 45. I think the biggest number that goes in is 3. So divide 3 goes into 24 8 times. 3 goes into 45 15 times. Done. Okay, so the big thing is the rule for division is keep, change, flip. That's keep, change, flip. That's what one of my teachers in high school, I think it was, showed me that. Keep, change, flip. Okay, when do we do that? With division. Only with division. Multiplication stays the same. Okay. All right, so now let's go down to something that's more our grade level. Okay? Okay, so this is multiplication. What were the rules for multiplying two fractions? Straight across. So we go 6 times 4, 24. X to the third times x to the third. So do we add them or multiply them? Add, good. So when do we add and when do we multiply? So when it looks like that, you add. When it looks like this, that's when we multiply. Okay? A power to a power. That's when we multiply. We don't have that. We have the top one. So that's why we add. And then the bottom is 21. Last step. Divide. What's the biggest thing that goes into 24 and 21? 3, right? Yeah, so this becomes an 8. That becomes a 7. Bottom, or letter B. Division. Well, first thing we do anytime we see a division is we do keep, change, flip. Keep the first one. Change the multiplication, flip the second one. Once we do that, you do the same thing you just did. So you get 80x to the third power over 45. I think you could divide them by 5. So that's 16 over 9. So you get 16x to the third over 9. Not too bad. Okay? The only difference with the other side?
Didn't you add the powers?
Yes. Oh, yeah. Sorry. Yeah. You're right. Yep. Yep. Nope. Yep. That's my mistake. Should be 6. Yep. Okay. The only difference with the other side is that these are all monomials, right? You have some binomials and trinomials. Well, we've been doing that. You guys did that. You guys did that with Mr. Lara on Wednesday, on how to simplify those and do those. So that's going to look more like what you guys did on Wednesday. Okay. So let's go to the back. Still multiplication. Multiplication. Okay? So now when we have binomials and trinomials, we do it a little different. So the first thing I'm going to do is I'm going to highlight each. So these are the two numerators. These are the denominators. The reason I do that is because first thing you do is you break down everything. Break down everything. What does that mean? Well, 10 is a monomial. How do I break down a monomial? You use something that you used back in elementary school. It's called the factor tree, right? So if I was to break down 10, it'd be 5 times 2. So we got 5 times 2. Seven. If I was to do a factor tree for 7, it wouldn't be very big because 7 is like 3. It would just be 7 times 1, so it's just 7. Okay, those are broke down. Now the green is not a monomial, it's a binomial. So how do we factor or how do we break down binomials? Right there. You guys have done that before. You guys did that on Wednesday, right? First thing is there a GCF? So on the green, is there a GCF besides 1? No. Is the difference of squares? No. So we leave it the way it is. That binomial stays exactly the same. The blue, same thing, it's a binomial. Is there a GCF? No. It's not difference of squares, so it stays the same. So neither of those broke down. That'll happen once in a while. Most of the time they'll break down. So now what do? This is our multiplication part. So the multiplication part means we're going to move everything under one fraction. So on top I have 5 times 2 and then a binomial. And then on bottom I have a 7 and a 2x plus 9. Oops. And then look for things to cross out, like you guys did on Wednesday. Is there anything I can cross out? So I can't cross out the x's because those are part of binomials. If there was an x here and an x here, that's a great point. If there was an x here and an x here, you can cross those out because those are monomials. But I can't cross out, the only thing I can cross out with binomials is the whole thing. I can't cross out these guys because they're different, right? And there's nothing here that cancels out, so this guy is actually already reduced. We didn't know that, but now we do. So now you can multiply. 10, 3x minus 10, 7, 2x plus 9. Done. Kind of looks like how it began because it was already reduced. It was already reduced, but you don't know that until you actually look at it, okay? All right, let's look at B right underneath. So B has everything. It's got monomials, it's got binomials, it's got trinomials, and it has division. So the first thing I got to do is take care of that division. So what do I do to get rid of the division? Keep, change, flip. So what does that look like? Well, the first fraction is going to stay the same. Change to multiplication. Second fraction flips. Okay. Okay, so now I'm going to do exactly what I did on the last problem. I have a numerators, 2 of them. I have denominators, 2 of them. So I'm going to go through this one by one. So I'm going to start with the yellow. Is the yellow a monomial, a binomial, or a trinomial? Binomial. So I'm going to follow the binomial steps to break it down, to factor it. First step, is it a GCF? Is there a GCF with the yellow? No. Is it difference of squares? Yes, it is. Yep, you guys got it. Just like last semester, we had difference of squares. That's going to still be there. So it's x plus and x minus what? 7. Good. Yellow is done. So let's go right across to the green. That's a monomial. 3x is a monomial. So how do I break down a monomial? Just like that. 3 you can't really break down. So it's just going to be 3 times x. That's all it's going to be. Green done. Pink. Monomial, binomial, or trinomial? Binomial. So let's go back to the binomial steps. Does it have a GCF? It does, right? What? X to the third power. We always want to take out the smallest power. So x to the third power. So what we're going to do over here is I'm going to put x to the third in front because it's a GCF, right? And what does that leave after I divide? X plus 7. X plus 7 is not difference of squares, so I'm done with that one. Green, pink is done. Last one is blue. Is blue a monomial, binomial, or trinomial? Trinomial. Okay, so I have steps there, right? First step is is there a GCF? No. Second step, ABC. So I'm going to do that over here. A is 1, B is -1, C is -42. So multiplies to be -42 and adds to be -1. What are the two numbers that multiply to be -42 but add to be -1?
-7.
-7, +6. So we get x squared minus 7x plus 6x minus 42. So I'm going to get x minus 7 and x plus 6. Okay, first step is done. They're all factored. Every single numerator and denominator is factored. Second step is the multiplication part. It doesn't really look like multiplication, but it is. What it is I'm going to put everything that's on top, everything that's on bottom. So let's go through this. What's on top? I have x plus 7, x minus 7, and 3 times x. That's what I have on top. I'm going to put on top here. I'm going to put the monomials first, and then I'll put the binomials second. Same thing on the bottom. I'm going to put the monomial first and then the binomial second. I have 3 binomials that I have to put down. Okay. That's the multiplication part when you put everything together. Doesn't really look like multiplication, but it was. Last step, look for the giant ones. What can I cancel out? X plus 7's good. X minus 7's. So we get 3 times x on top, or 3x. On bottom, I get x to the third and x plus 6. So I go to Delta Math, and it says red arrow, wrong. I didn't do anything wrong. I forgot something. What did I forget? One thing I forgot. It has to do with the 3x.
But it has 3x?
So yeah, so I can do that. That's not wrong. So if I put it as 3x, it wouldn't mark me wrong. So I could put it like that too. It'd still be wrong though. What has to do with the 3x and something on the bottom?
Oh, make it x squared and then make that.
There you go, yeah. These guys here. Let me use a different color. These guys here. These guys are both monomials. I can cancel out monomials with monomials. So just like Joseph said, I can take away a power here and a power here. So that guy is going to have no power. 3 is going to have 2 powers. I can't do it with this guy here. This guy here is off limits because it's part of a binomial. Because this top, 1 is a monomial, 1 is a binomial. You can't do that. But since they're both monomials, I can cancel out. Now I'm done. Now, green check. Okay. All right, so what I want you to do now is B. Use that to do letter B. It's very similar. Letter C. Letter C is very similar to the one we just did. So I want you to try that one, and then we'll do letter D together. If you're stuck, start with breaking everything down. Keep going, but I'm just going to start, so just to catch up. Okay, so the yellow again is a binomial. Doesn't have a GCF, but it's difference of squares. Okay, So we can rewrite it as x plus 6 and x minus 6. The green is, again, just 3 times x. The pink is a trinomial, so I can break it down using trinomial methods. So we get 30 and negative 11. The two numbers that multiply to be 30 and add to be negative 11. Negative 6 and negative 5. Okay, so we get x minus 6, x minus 5. And then the blue is a binomial with a GCF. X squared. Don't forget to put the GCF in front. Anytime you do a GCF, it always stays there in front. Okay, so all colors are factored. Once you do that, next step is put everything together. Everything on top goes on top. So 3 times x, and then x plus 6 and x minus 6. On bottom, you'll have x squared, and then you have 3 binomials. Okay? Look for things to cancel out. X plus 6 and x plus 6. X minus 6 and x minus 6. And then the monomials here I can cancel out too. The GCFs were monomials, so I can cancel those out. So this guy's going to go away, this guy's going to lose a power. So on top I just have 3. On bottom I have x times x minus 5. And you're done. Okay, so like I said, today is more, it's not really multiplication and division, it's more of simplifying. It's just more simplifying, really what it is. Okay, that's why there's not as many problems today as you guys did on Wednesday, because you guys have had practice already. Last one more and we'll be done. Last one and we'll be done for today. All right. This one's already multiplication, so we don't need to do any keep, change, flip. Only with division. Numerator. Numerator. Denominator. Denominator. Go color by color. Let's start with the yellow. Yellow is a binomial. So start with a GCF. Does have a GCF. 6x to the third power. 6x to the third power. 6 divided by 6 is 1. If I take away 3, I have x minus 5. Not x minus 5 is not difference of squares, so I'm done with the yellow. Green. Green is a trinomial. Doesn't have a GCF. So we'll go 1, negative 5, 4. So I'm looking for the two numbers that multiply to be 4 and add to be negative 5. So they're both going to be negative. There you go. -4, -1. X squared minus 4x minus 1x plus 4. So we get x minus 4, x minus 1. Green done. Okay. Now let's move to the pink. So the thing with the pink, though, is it's trinomial, but it also has a GCF. I can divide all of the pink by 6. So I get x squared minus 9x plus 20. Still a trinomial, so I still can do A, B, C, and stuff like that, but I can do GCF. So anytime there's a GCF, do GCF. So we get A is 1, B is -9, C is 20. 20, -9. Two numbers that multiply to be -9, multiply to be 20, add to be -9.
-5 and -4.
Yep. Minus 5x minus 4x plus 20. So we get x minus 5 and x minus 4. But I don't want to forget my GCF as well. I want to put that there too. Last one, blue. Blue also has a GCF. X. Okay. A, B, C. Seven, -8. The two numbers that multiply to be +7 add up to be -8. -7, -1. Yep. Okay, so I get x minus 7 and x minus 1. And then my GCF of x. I want to make sure I put the GCF of x there too. Okay, that's the most tedious part because you got to break down everything, and if it's a trinomial or a binomial with GCFs and all that, sometimes it could take a little bit of time. Okay? Last step. I call this take inventory. What do I got? What do I got on top? What do I got on bottom? So on top, I have an x, 6x to the third, x minus 5, x minus 4, and x minus 1. I have all of that. One monomial and 3 binomials. On bottom, I have 6 and then x. Put the monomials first. And then I have 4 binomials. Last thing, look for things to cancel out. Look for things that will cancel out. X minus 5, x minus 5. X minus 4, x minus 4. X minus 1, x minus 1. So on top, I have 6x to the third. On bottom, I have 6x and then a binomial. One binomial left. Again, I put it in delta math, it says wrong. What did I do? What did I not do? What did I forget to do or haven't done? The sixes, yeah, the sixes. So the sixes, because they're both monomials, I can cross those out. And then the power. That becomes a 2, that goes away. Very, very, very last question. Can I do this? Can I take away another power? I got x here. Can I take away x and a power here? No, you're right. Why not? It's a binomial, right? This x is part of a binomial. This x is part of a monomial. They don't go together. They stay separate. Okay? Good job. You guys are done? Okay? And we are done.